Hello, today I'm covering part 2 of section 7.1. So we're still completing the table using the idea of repeated multiplication. Then in the final row, use the pattern to write the exponent rule in general. The first one is done for us. These problems also use the commutative property of multiplication a lot, which says that the order of multiplication does not matter. In other words, 3 times 4 is the same thing as 4 times 3. So, like said, the first one is done for us, which is 3 times 4, quantity to the second power. Well, that means 3 times 4 times 3 times 4, which is the same as 3 times 3 times 4 using the commutative property, which then is 3 squared times 4 squared. So repeating this for the next one, we have 2 times 5 to the third power. So that's 2 times 5 times 2 times 5 times 2 times 5. Then using the commutative property, this equals 2 times 2 times 2 times 5 times 5 times 5. So then you get 3 2's, so 2 to the third power, times 3 5's, which is 5 to the third power. The next one, 6 times 3 to the fourth. Now that's 6 times 3 times 6 times 3 times 6 times 3 times 6 times 3. And then again, using the commutative property, we can rearrange it where all 4 6's are next to each other. So 6 times 6 times 6 times 6 multiplied by all 4 3's next to each other. 3 times 3 times 3 times 3. So we get 6 to the fourth power times 3 to the fourth power. 4 times 5 to the second power. Well, that's 4 times 5 times 4 times 5. And then using the commutative property, that's the same thing as 4 times 4 times 5 times 5, which is 4 to the second power times 5 to the second power. So then what is x times y quantity to the n power? I'm hoping you realize we kind of like distribute exponents over multiplication. So this is x to the n times y to the n. Does this rule work for 1 times 3 to the third power? Explain. If so, what is the result? If not, why not? Well, let's see. 1 times 13 to the third power. Well, I know without the rule, this is 13 to the third. With the rule, it would equal 1 to the third times 13 to the third. But 1 to the third is just 1, and 1 times anything is just it. So we get 13 to the third. So these match. So yes, the rule works. A good name for this rule is a product to a power rule. Can't just call it the product rule because we already used it, but it's product to a power. So in other words, the product is inside parentheses. Another one. So this one we have 3 over 2 to the third power, which is 3 over 2 times 3 over 2 times 3 over 2. But then, according to fraction multiplication, we just multiply all the numerators and all the denominators together. So we get 3 times 3 times 3 on top over 2 times 2 times 2 on the bottom, which is the same thing as 3 to the third over 2 to the third. So 5 6 to the fourth power. Well, that would be 5 over 6 times 5 over 6 times 5 over 6 times 5 over 6. Then using just the definition fraction multiplication, that is 5 times 5 times 5 times 5 over 6 times 6 times 6 times 6. So then we get 5 to the 4th over 6 to the 4th. Then we have 1/2 times 1/2 for 1/2 squared, which is 1 times 1 over 2 times 2, which is 1 squared over 2 squared. Next problem is 2/9 to the 5th. So that's 2/9 times 2/9 times 2/9 times 2/9 times 2/9, which equals 2 times 2 times 2 times 2 times 2 over 9 times 9 times 9 times 9 times 9. So then we get 2 to the 5th over 9 to the 5th. So I'm hoping you see from the previous examples that exponents also distribute over division, not just multiplication. So x over y to the n power is x to the n over y to the n. Does this rule work for 5 over 3 to the 0 power? If so, what is then result? If not, why not? Well, 5 over 0 to the 3rd power, I know 5 over 0 is undefined. This rule doesn't really pertain to it then. If you happen to use the rule, though, 5 over 0 to the 3rd is 5 to the 3rd over 0 to the 3rd, which is the same thing as 5 over 3 to the 0, you still get undefined. So even if you did use the rule, you get the same answer, but because we're talking about an undefined quantity, that's why the rule doesn't make sense. And then what might be a good name for this rule? Well, quotient to a power rule. And then part 3, properties of exponents summarized. Now that we've seen how we can unpack exponents as repeated multiplication and use properties of multiplication and division to simplify the resulting expressions, let's summarize our findings below and assign names to these properties. The properties of exponents, where a and b are real numbers but b is not equal to 0. And then in our whole numbers, we have the following properties pertaining to exponents. A to the m times a to the n is a to the m plus n, and a over m divided by a over n is a to the m minus n. And together we call these the same base laws, since the factors have the same base. Next, we have a to the m times b to the m. So this is using the product to a power rule, but backwards. So because these have the same exponent, I can rewrite it as a times b to the m. So when we did the examples, we went from the right to left, but it's okay to go from left to right. Same with a to the m over b to the m. That will be the same thing as a over b to the m. And we call these the same power laws, since the factors have the same power. A to the m to the n, well, we already said this is a to the m times n, and we call this the power to a power law, since it involves a pair of exponents. And then finally, a to the 0 equals 1 if a does not equal 0. If a equals 0, then it's undefined. And a to the 1 equals a. We call these the null property and identity property of exponents, respectively. Final example, simplifying the following expressions using properties of exponents. So the first thing we're going to note is that this is going to be x squared times 1 times z squared, since y to the 0 power is 1, which is x squared times z squared, which then we can use our product to a power rule to say this is xz to the second power. Okay. Next, I'm actually going to use a fraction property first, that this is the same thing as x cubed over x times y to the 5th over y squared. That way I can then use the quotient rule of same bases for both of the separate fractions, remembering that x is the same thing as x to the first power. So then we get x to the 3 minus 1 times y to the 5 minus 2, or x squared times y cubed. Next, we have x to the 5th times y to the second power. Now, using our product to a power rule, this is x to the 5th to the second power times y to the second power. And then using our power to a power rule, this is x to the 5 times 2 times y to the second power, which is x to the 10th times y squared. Then we have x squared times y times z cubed over x times y times z. So this is x squared over x times y over y times z squared over z. Z cubed over z. So then we get x to the 2 minus 1 times, well, y over y is 1, times z to the 3 minus 1, which then simplifies to xz squared. And that is it for section 7.1.